Hello everyone. Today I'm going to discuss the fourth problem of AtCoder beginner contest 346, which is Gomamayo sequence. So what is the problem? So we are given a string s of length n consisting of 0 and 1. So it is a binary string. So a string t of length n consisting of 0 and 1 is a good string if and only if it satisfies the following condition. There is exactly one integer I such that the ith and the ith plus 1th character of t are same. Okay. For each I from 1 to n, you can choose whether or not perform the following operations with cost ci. So what we can do, we can flip the ith character. If we flip the ith character, it will cost us ci. Okay. So what we are given, we are given a integer n, a string binary string s of length n, and the cost to flip each character in s, which is given in the c array. Okay. So so let's take one example and understand how we can do that. Let's take this example only. So 5, this is nothing but this. Okay. So we have let me take the brush. So we have three zeros and two ones, and these are the cost array. So what we can do, let's say we are doing this, we are doing only 1 0 0 1 1 1 0 0 1 1. So what are the number of integers where I and the I plus 1 characters same? Okay, the number of characters where I and the I plus 1 character are same are these two. So this is not a good string. So what is a good string? Let's say we have made the string like that, 1 0 0 1 0. Here only one I, such that I and the I plus 1 character are same. So this is a good string. If we make this string this as this, what is the cost for doing that? So we are flipping the first index or zeroth index, you can say, and we are also flipping the last index or the fourth index. So the total cost is 3 plus 4 7. So this is the optimal way to convert the given string to a good string. So our answer will be 3 plus 4 7. So let's check that the answer is 7. Now you can check the second example also. This is a good string. 1001 is a good string because there is only one occurrence, where exactly one occurrence where two characters are matching, the two consecutive characters. Now let's say 0 0 0 1. Let's say you have taken 0 1. This is not a good string. You have to make this either 1 1 or 0 0. Okay, that is one edge case which I have missed, which is here, that there should be let me check. uh, there is exactly one. This should be made bold. I think I have thought that this is less than equals to 1, so that's why I have one wrong answer here. So how we can solve this problem? So let's jump into the observations. So what are the observation? Our first observation comes from the constants. So constants on n is 2 into 10 to the power 5. So constants on n is 2 into 10 to the power 5. So overall time complexity will be something like order of n into some constant, or it could be order of n log n also, order of n log n. Okay, so I have solved this problem with order of n into something, some constant. Now what is the brute force solution? So the brute force solution could be, let's say uh, the brute force solution is the simple recursion that what we are doing. So we are changing the ith character to either 0 or 1. So let's say we are at some index I. So what we have two possibilities. We can make the current character to 0, make si as 0, and move forward, and we can make the si as 1 and move forward. So there are two possibilities. So there are 2 to the power n number of possibilities. So we'll check 2 to the power n number of strings and their costs, and check if they are good strings or not. So this is the brute force solution that I am talking about. So this is definitely not possible, so let's not go into that. Now we'll check what could be the possible recursion state. I have solved this problem using recursion and memorization. So let's go into the possible recursion state. So for forming the recursion state, the first variable will obviously be our the index I. And what are the second variables? So what is the important thing? The important thing is that what is the previous character. So what we can say, that last character. What is the last character? So what is the last character? One. What is the another parameter? Is it sufficient? No, it is not sufficient. We have to take another parameter which will give us that if we if in the prefix of till I, there is one index such that si equals to si plus 1. So let's call that flag. So what are these three values, three parameters? First one is the index, second one is the what is the last character, and the third one is that if in the prefix it is flag equals to 0, means that in the prefix there is no index I such that si equals to si plus 1, and if it is 1, that means there is exactly one character such that si equals to si plus 1 in the prefix. Okay, so what are the possible values here? There are possible values of I is n values, and the what are the possible values of last could be either 0 or 1, so it is also 2. And what is the possible value of flag? It is also 0 and 1, so the value of this will be 2. So total number of recursion state using memorization, which will be order of 4 into n, which is definitely possible. Now let's go into the possible transitions. Okay, so from I last flag, what we can jump to. Okay, so let's say if flag equals to 1, this is the simpler case. If flag equals to 1, then our si should not be equals to last. Okay, so because if si equals to last, then the flag value will be 2, which is not possible, because we can have only one index where si equals to si plus 1. So si not equals to last, so our possible value will be I comma I comma last, 1 minus last, or you can say last or 1, 1 I comma 1 minus last comma 1. This will be plus if last equals to si. If last equals to si, we have to add ci, otherwise we have to add 0. So this is the recursion state for if flag equals to 1. Now if flag equals to 0, there are some possible cases where last equals to si and where last not equals to si. So I will explain the states in the code. Okay, so let's jump into the code now. I hope you get the what are the variables are, and we are using dp, so that overall time complexity and space complexity will be order of 4 into n. Okay, now let's jump into the code. So here I have taken c as like the cost array as a, and that variable is dp. Dp has 2 into 10 to the power 5 into 2 into 2. Okay, so here I am taking the taking n and s as input, and we are setting all the values of dp as -1. Okay, now again we are taking the input as the all the cost array. Okay, now let's jump into the recursion state. The base case is if I equals to n, that means we have iterated over all the string, we have iterated over the entire string. Now if flag equals to 1, that means there is exactly one character where si equals to si plus 1, then we are marking it, we are returning 0. Now if there are let's say there are no indexes where si equals to si plus 1, then this condition comes in where this exactly that we have to have exactly one integer. So in that case, if flag equals to 0, we are returning infinity. Now this part is for memorization. Okay, now if flag equals to 1, I have explained this case. Now let's jump into if flag equals to 0. Now if si minus 0 equals to last, that means that the current character is equals to the previous character. Then there are two states. We can jump to the next index with the current value last comma 1. That means we have one index I minus 1, such that I minus 1 and I are equal, and else we can flip the current character with ai cost, and the flag value will be 0 here. Now if si minus 0 is not last, then what we can do, we can mark this array I plus 1 comma last comma 1, because we are not we are flipping this, and else we are doing I plus 1 comma 1 minus last comma 0. So you can take some pen and paper and check that what if we are flipping. If we are flipping, we are adding ai, and if we are not flipping, we are not adding ai, and how the value of flag are changing. Okay, so total there are 6 cases, 6 transitions. If for there are two transitions for flag equals to 0, and there are 4 transition if flag equals to 1. I will provide the link of the code in the description box. Please go through the code, and in the paper write the transitions. I hope you like the video. If you find this video helpful, please like the video and subscribe to my channel. uh, If you have any doubt in any part of the code or explanation, please write in the comment section. Thank you.